Yeah, good morning and good evening, everyone. My topic is today's intelligent approach to code-driven test execution. So this is the topic. I have paper on this. So let's start with this. Okay, before going ahead, I just wanted to introduce myself. I am Rohit Khankhoje from Indiana, USA. I'm an independent researcher in the industry background and working on the e-commerce company called Inception based on California, USA. I work as a test automation architecture and have more than 16 years of experience in automation testing and different domains like logistic and e-commerce companies. I have some papers published already and I am part of the many editorial boards. So mostly my research area is the artificial intelligence and machine learning, reference to automation testing and the software industry and developing the design and the framework for that. Moving on. So today's topic, I have a couple of topics in the agenda. So I'll introduce my paper topic and the background of that. Then I'll talk about some challenges in the traditional text execution. What are they? And later design and the data collection, how the model is designed and the data, how the data is collected. Then the machine learning model information, then benefits of the design and what are challenges and the conclusion on this. So first of all, about the code-based intelligent execution. This article presents a new and intelligent approach to test execution that is driven by code and utilize machine learning to greatly improve adaptability and accuracy in the testing process. Traditionally, testing method often struggle to handle changes in the code, resulting in the less than optimal test execution. Our proposed method utilizes machine learning techniques to predict the impact of the code modification in the test results, allowing for more precise test execution strategy. We have demonstrated significant improvement in the test execution efficiency, reducing unnecessary tests and speeding up the feedback cycle. The following discussion examining this finding address potential limitation and suggestion in the future areas. Our methodology explain how Git commit add the updating feature and how the machine learning model predict the updated feature name. This predicted feature name is given to integrate it into behavior-driven test, select the execution using the standard BDT frameworks. Incorporating machine learning into testing process, developer can achieve greater precision and effectiveness, making significant progress in overcoming challenges opposed to change the code in modern development environment. The effectiveness of the testing methodology play a crucial role in ensuring dependability and functionality of the application. Traditional approach to the testing often encounter difficulties in adapting the rapid pace which is code change occurred. This study tackled this presenting issue by introducing intelligent method for executing test driven by code utilizing machine learning. The primary aim of study is to develop and implement intelligent method executing tests driven by code. There are two specific goals: introducing machine learning model. The purpose proposed machine learning model capable of intelligent analyzing code modification and predicting their impact, feature, and the need specific test to feature only. And then second option goal is optimizing test execution, implementing model to selective execution test based on the impacted code change. So before going, the traditional test execution have some challenges. So because of that, we need to propose this solution for the including machine learning things. So first, the challenge is time consuming process. Manual test execution can time consuming, particularly for large and complex software projects. Regression testing often perform repeatedly contribute the extended testing cycle. Second is limited resource utilization. Dedicated testing resource may be underutilized during certain phase of development life cycle. So test environment and configuration are not always optimum and maximum efficiency. Third is redundant test runs. Running the same test in set of tests of every code change, even the changes are minor, lead to redundant test runs. This redundancy consume resources and delay feedback on critical changes. Fourth is inadequate coverage of code changes. Traditional testing approach may struggle to adapt frequent code changes. The challenge lies to ensure the comprehensive test coverage, especially agile and rapid evolving development environment. And the fifth is dependency on manual decision making. Manual decisions on which test execution for each code change can lead to subjective choice. The process lack the ability to analyze data and comprehensive and optimum decision making. So this is the design approach which we are proposing. In this context, software development importance of providing comprehensive information within the code commit message cannot be overstated. Development can require to input specific data based on this table and during the code commit. This data subsequently utilized determine which feature test should be executed for the application testing. The machine learning model leverage the Git logs and make prediction utilizing the classification techniques to identify altered feature and the feature that required the testing. The first development must explicitly mention the files and path affected by commit. The commit message should clearly specify the nature of the change, whether it's bug fix, new feature, performance enhancement, including the feature name, and identify associated with the code change, provided the context of the user story or the features. By incorporating this information into commit message, the Git log become a valuable resource for data for machine learning model. The model are trained identify pattern in the commit message and exact relevant information, automating the prediction of the feature name based on the code change. Integrating machine learning prediction with automated examine frameworks such as Cucumber PDD enhance the efficiency in testing process. The predicted feature name can employ the Cucumber scenario and dynamic adaptive. This can map as features with the feature test with the Cucumber frameworks. These are the some format of the test that can be used different test also. For this presentation purpose, we are using Gherkin format test, how the Java code and the Gherkin format test integrated with the machine learning to provide the data. Tagging Cucumber scenario with the feature name after obtaining anticipated attribute derived from the machine learning model, it is imperative to utilize the same attribute nomenclature in order to execute Cucumber-driven framework development in the test run. In this BDD test scenario is commonly denoted by particular feature. It is essential to establish a correct between each scenario or feature file and label that align with the characters of the test. For instance, if Cucumber scenario is related to feature denominated user authentication, label it the user at the rate user authentication. Automation test selection based on predicted feature name. In order to execute BDD test dynamically, it is necessary to establish the feature name within the runner class in the BDD framework. After machine learning model, the feature name and specific code alteration utilization the feature name to dynamically select the automation examination. Run only selection. In the Java code configuration run, test runner is execute solely the scenario labeled with the feature name. This ensured the solely examination associated with the feature are implemented. Conducted the automation examine using the configure Cucumber runner. This approach facilitates the selective execution of examination based on the feature name, permit the target and effective testing process. By integrating machine learning, the Cucumber BDD and labeling scenario with the feature name, one established a dynamic and adaptive testing framework. The approach optimized the test suite in selective execution solely with the examination associated with the feature. The execution time, resource utilization with the upholding compressive this test coverage of identified feature. This dynamic and adaptive testing framework optimizes the test suite selective execution, examine based on predictive feature, reducing test execution time, resource utilization, and maintaining the compressive test coverage. In the discussion, it acknowledged that accuracy of prediction relies on historical data quality, strategy, and handling the inaccurate prediction and potential area of improvement, including dynamic test suite generation and generating the CI/CD pipeline are highlighted. The approach demonstrates the sustained advantage over traditional method lays on foundation of future innovation in the intelligent software testing. Model workflow. What are the model workflow layers? There are a couple of model workflow like data collection, data pre-processing, and feature engineering, model training, prediction, and integration with testing framework, test selection and execution and feedback loop. So first is data collection. Historical data for version control system, typically Git log is collected. The data collection information about code commit, including commit message, file modified, and the associated feature name and identifiers. Second is data pre-processing. The collected data undergo pre-processing to clean and organize if model training. This may involve tokenizing commit message, extracting relevant information like file, type of change, and feature name, and creating a structured data set. Third is feature engineering. Relevant features are extracted from the data to train the machine learning model. This includes information such as file path, type and changes, bug fix, new feature or performance, and associated feature name. Next is model training. The pre-processed data used to train machine learning model, commonly used model for text classification tasks like predicting feature name from commit message, including neutral language processing NLP models such as recurrent neutral language and transform based model. Prediction. One of the model is once the model is trained, it can predict feature name based on new or unseen commit message. The model take the input, the commit message, relevant information, and output the predicted feature name. Integration with the testing framework. The predicted feature name are integrated into testing frameworks such as PDD, scenario test cases, and tagged with the predicted feature names. Test selection and execution. During this execution, the testing framework dynamically select and execute the test case based on tagged feature name. This allows the targeted and efficient testing process. Feedback loop. Continuous learning and facilitated through the feedback loop, the outcome of execution test along with inaccuracy and mismatch are used to redefine, update, and machine learning model. This ensures adaptation and the change code pattern over time. In summary, machine learning model is a context leverage historical commit data to learn pattern and associate between commit message and feature name. The trained model enable automation for predicting feature name for new code change, creating dynamic and adaptive testing framework that enhance testing efficiency and accuracy. Continuous refinement and model based on the real world testing outcome contribute for ongoing improvement and adaptation. Benefits. There are some benefits to use these new models for compared to the traditional. First, foremost, is efficiency and improvement. The approach optimizes test execution to selective running tests related to specific code change. Second is resource utilization. The execution only relevant test associated with predicted feature. The approach minimizes resource utilization. It ensures the resource, including testing environment and infrastructure, are dedicated to essential tests, reducing unnecessary overhead. Compressive test coverage. Despite selective test execution approach, maintain compressive test coverage by dynamically adopting to code change. This ensures the critical area the application are thoroughly tested. align with the evolved software landscape. Later on, the adaptability of the code change, machine learning model continues learn from new changes and testing outcome, adapting the evolving nature of software adaptability, enhance the model predictive accuracy over the time and accommodate rapid change in code base. Dynamic test suite generation. The approach facilitated dynamic generation of the test suite based on predictive feature. They provide precision control over the scope of the testing, allowing team focus on a specific feature impacted by the code change. Integration with the CI/CD pipeline. Enhancing integration with the continuous integration and continuous delivery pipeline streamline the testing process. Automation and intelligent test execution become integral part of the development workflow, promoting seamless collaboration between the development and the testing team. Real-time feedback mechanism. The incorporation of the real-time feedback mechanism ensure that machine learning model is continuously updated based on executed test outcome. This promise continuous learning and adaptation enhance the model accuracy and reliability. Collaborative testing practice. The approach encourages collaborative testing practice where developers actively contribute the testing process by validating and refining prediction. This collaborative approach strengthens the synergy between development and testing team. Paradigm shift in testing practice. The intelligent approach introduces paradigm shift by leveraging machine learning to trail the testing effort. It makes the departure of traditional method, offering the more dynamic, adaptive, and effective framework for software testing. And the foundation, and the last is foundation of the future innovations. By demonstrating sustained advantage over the traditional method, the approach established the foundation of future innovation in the field of intelligent software testing. It encouraged the further explosion of advanced machine learning techniques and practice. In conclusion, intelligent approach of code-driven test execution bring about significant improvement of testing efficiency, adaptability, collaboration, laying the groundwork for continuous enhancement in the software testing methodologies. Some of the challenges include the models for the software testing. The quality of the training data is the big challenge. The accuracy of machine learning model rely heavily on the quality and diversity of historical data. Limited and biased training data may compromise the model ability to accurately predict a future name, especially in the rapidly evolving code base. Second is rapidly code-based evolutions. The scenario where code base evolve rapidly, predicting feature based on history may become challenging. The model need to adapt quickly in the changing pattern, required continuous refinement and maintenance in accuracy. Error handling in mechanism. Robust error handling mechanism are essential for handling inaccurate prediction. Strategy need to revise, manage unforeseen scenarios, false positive, false negative, ensuring the reliability of intelligent testing approach. Interpretability of Ensuring the interpretability and explainability for machine learning model is crucial. Stakeholders, including developer and a tester, need to understand how the model make prediction to build trust and collaboration. Dynamic tests suite generation. Methods for dynamic generation tests would based on the prediction and feature posed to challenge the fine-tuning scope of testing dynamic required careful consideration of avoid under testing and overstating. So in conclusion, we have unveiled the innovative strategy of test execution based on the code, leveraging transformative capability of machine learning, predicting code alteration specific functionality. Our finding underscore the pivot role of a strategy of reshaping traditional testing methodology and efficiency of dynamic software development environment. Unlike conventional approach in the employ to fix set of tests to every code change, intelligent approach offer the multitude of advantage. Targeted testing, direct effort, solely relevant examination linking to a specific attribute affected by code alteration. Ensure focused testing on area with the potential risk, resource optimization, prevent unnecessary tests, optimizing resource utilization for quicker test build and execution. Adaptability is a key advantage, aligning with the ever-changing code base, making it well suited for agile development environment, enhance development product, accelerate feedback on code change, reducing wait time for test suite and expedite issues. In conclusion, our investigation investigation fundamental shift to code guided test execution, presenting sophisticated and adaptive testing paradigm. The proposed intelligent approach emerging enhance testing efficiency, development productivity, overall software quality. As we navigate ever evolving landscape of software development, intelligent